on some metal chassis or metal bar, connect them, and then the currents can flow like this, and they won't create much problem. Take them one step further. Again, we have this loop. Now we put a metal plane under it. Just put everything on the chassis. It's a white metal. If you have it, why not? And do it like this. You connect every box to this metal plane, and then the noise from the noisy cable will go back through the metal plate. If the plate is not available, you could use a wire mesh. So like a concrete, in case we'll talk about it, if you have wire mesh in concrete, you can use it for this same purpose, to have the current flow back there, the common mode current. But you need to connect all your equipment to that protective plate or mesh you're using, otherwise it doesn't work. And you do that with glands or other means. It's always a connection to the connector plate on the equipment. You can imagine, when you put another place, there would be a current flow over your camera. You don't want that. Okay, special form, we have seen it already, the cable guide. We used it for our experiment, but now we know this is a sort of current boundary, and we can use it with cables. In the previous experiment, I used it with single wires, but we can do the same experiment with cables. The thing is you need to get it off. I have a spectrum analyzer here, in this box. It has a tracking generator which generates some frequencies, and here you can see the frequencies and the amplitude of the signal I receive back. So I'm listening to the passive cable, both are terminated in 50 ohms. I put a tracking generator on the noisy cable, source cable, and then you can see the effect. Cables, I use the wrong coax and the wrong twisted pair, because if you use good cables you can get this crosstalk, but for these short ones you would never see it. So I use little not so good cables just to show you the effect. 50 ohm load again. This is my input, sensitive input, and this is my generator. connect them together, so just input to output. And you look at the screen using our little camera here. Yeah, okay. So remember the picture. That line you see. You can see there's the yellow line on top of the screen. Okay. Which is low frequency band being 200 megahertz. Yeah. We need a camera stand.
Yeah, that's me.
Okay, it's you, yeah. Okay. But you're not stable. Okay. Stable stands are more expensive. No. It's the connection. Now I connect my cable system here. So if you disconnect it, it goes to the bottom line. It's noise, actually. I put the noisy one on the black and white, and the other one, the sensitive, measuring input on the other. And you see, there's a noise over the whole band between these two cables. Make noise. Separating them, what they always say, separate two cables doesn't help one bit. See? Well, a little bit, but okay. Few dBs. Huh? Doesn't really help. So separating cables is useless, except if you have something else, an alternative. If there's an alternative, yes, then you can separate. So the alternative is, again, our current boundary or metal plate. It really helps. See, I mean, this is the effect. And then if you put it nicely on top of your metal also, you can get it, make it even better. See? So it does need to make contact. If it doesn't contact, it doesn't work. It only works if you have good contact. There's still a little interference here going, but it's low, and there's a little opening here, and you can see it in the high frequencies. No contact, everything is bad. So yes, you need an alternative connection, which is good low impedance contact. Okay, so this is one. This is the ideal user metal plate. Now we go to the practical situation. Okay, I have my cabinet here, and let's say on a ship we have a big cabinet and it's standing there and the ship is shaking and moving, so we cannot really connect it to the deck because then it would be mechanically damaged. So I want to a new solution. I have these cabinets standing here. You see the noise, and I ground it with a wire. See? It does something, but you see, it's not the same as this. So we can make it better, but okay. Let's leave the high frequencies for later. So this is not so good. It's at least 30 dB less. Every block is 10 dB. Better would be maybe white metal. White metal here. Put white metal under it. Well, that's a little better. 10 dB better. But it's still not good. Why is it not good? Well, see it here. An opening. This opening here is the problem. The cable needs to be against the metal over the whole length. Put it on the whole length. Good connection. Still, I need more hands. You know, you have a few hands left? Can you help me? Close all the other. Yeah, again. Okay. So, if you succeed in bringing it all to the metal, make all look small, then you can get it better. No, quite good. Separate them, maybe this loop should be here. Far away. See this little black loop here, and then you squeeze it together. So you can make it better.
They're always so expensive.
It's already low. I mean, it's 30 dB less than what it was initially. If you have no suppression, it would be 0 dB. 30 dB is a factor of 30, so it's already